afternoon or morning, depending on where you're joining us from. And today we've got one of the expert-led sessions where we get someone who's an expert in his niche to come present to us. And today we've been lucky to get Guy. I'm going to do a bit of intro so that you get to know him more. But he's someone who is an expert in his own aspect of the data space. So the way today's agenda will be is I do the intro. I will have to compress it from 5 minutes to 2 minutes. And today's topic is on lineage-driven cost and performance optimization, best practices for Snowflake users. So it's going to run for about 45 minutes, then Q&A. And to make it easy for us, you can put your questions in the chat and we'll take all the questions at the end. So if you see something that's interesting to you, you've got a question based on what the presenter is talking about, don't forget, put it in the chat and we're taking note. I'm going to do a thumbs up to let you know that, yes, I've acknowledged your question. We will handle them at the end. And wrap up should even not take 2 minutes, but I just had to put 2 minutes there. And this is just to let you know that we've got other interesting sessions lined up. So for March, we've got someone, the supervisor for City of Toronto's Open Data Program is going to be taking us on City of Toronto's Open Data Program, Mark Nichols. And we've got also we've got Sabine amongst us. He's in this session right now. He's going to be taking us in April. I'm just waiting for additional details on his session and his flyer will be out. But for May, we've got Venu Amancha, and he's going to be taking us on Enterprise Data Lake and Data Warehouse. So today's presenter is Guy Biecher. He told me how to pronounce his last name. I hope I did it correctly.
It was good. It was good.
Oh, okay, thank you. So he's a seasoned data professional and visionary. He's also the co-founder and CTO at Seemore Data. He's got a career that has spanned multiple companies, and he's passionate about data, and he's a core tech person. From my little conversation with him before we started, he's not a salesy person. He's not the kind of people who you listen to and you'll be like, okay, where's the core of what I was trying to get out of the session? Is someone that I know you will benefit a lot from hearing him speak today. And is it okay, Guy, if I share also your LinkedIn in the chat? I know we shared it in the announcement, so
Yeah, of
just
course.
checking. Okay, great. So I'm going to
No
share
problem.
how you can connect with him on LinkedIn. And right now I'm going to get out of his way and let him take us for this session. So I'll stop sharing my screen and Guy, over to you.
Thank you, Michael.
Yeah, you're welcome.
All right. So just let me know that you can see my screen.
Yes, we can.
All right. So yeah, today we're going to talk about Lineage and how Lineage can actually help us understand um, some cost opportunity that we have in our data platform. I know that probably for those of you who use like a Lineage tool, the reputation of data Lineage tool is pretty bad right now in the industry. Not a lot of engineers know how to do it, and I think for one of the first time actually making the lineage proactive, it helps you understand how all of your data pipeline cost and the interaction between the producer and the consumers. We'll see it like in a few slides. But first of all, yeah, nice to meet you. Michael introduced me, but I'm Guy Biecher. I'm the CTO and co-founder of Seemore Data. I think in the last 12 years in the data software engineering world. I was one of the first design partners of Snowflake like 8 years ago. I worked closely with their engineering team on features like search optimization and clustering columns and query acceleration service and many other goodies that Snowflake has. And I'm a huge fan of Snowflake. I think it's one of the best product and best technology out there in the industry right now. Um, so let's start. Um, I think that the problem of cost in an organization, it's we call it like cost is a second class citizen. And what does it mean by that? That of course that everyone wants to reduce cost, everyone wants to manage their costs. Um, but it's always like a less priority. The only reason that organization wants to like manage their costs, it's if the CFO gets angry and he decided that this year he doesn't want to increase the Snowflake budget, or we out of credits of Snowflake like 4 months before we need to renew the contract with them. Um, and we're seeing a lot of organization, the way they handle it, and I was the head of data engineering and managed it exactly the same. So like every quarter we did like those hackathons. So we're like we understand like the bill is get exploded, and then we're decided that we're stopping like the work for like a week, and then all the engineers are focused on trying to find like those long hanging fruits and to understand how we can reduce the cost. And then like after a week we actually did like succeeded to like decrease the cost by 10%, but few months after it's the cost increasing again, and again we're not can't manage it. I remember the day that when we signed the first contract with Snowflake, it was like 40K. We did like a migration from SQL Server into Snowflake, and when I left the last company, I actually the last contract with Snowflake was like $500,000 annually. I promised to everyone that like Snowflake is going to be much cheaper compared to SQL Server. It was not the case, and the reason for that Snowflake can be super expensive on one end, but it can be also cheap for the other hand because it really depends how you manage the costs in Snowflake and how you use Snowflake. So those are like the kind of the things that we're going to discuss like in this presentation today. Um, and I hope that it will help you some to manage the cost better in Snowflake. So I divide like it to four main steps. How it's from like how do we see like the optimal optimization journey? So the first step, of course, it's like we need to create observability, and in a second we'll see like how looks like a good observability. But observability, it's not like just go over the query history, try to understand like the most expensive query, try to optimize that. Observability we could create it much better than that. The second part, it's ownership. So most of the time what we're seeing in organization, it's that the one that's responsible on the cost, it's like maybe like a senior data engineer in the team, or maybe it's the head of data engineering. But most of the time, it's like a person in the team that is like trying to reduce the cost in the data platform. Um, and we're thinking that the ownership should be distributed to anyone in the team that basically creates like any processes inside Snowflake and create costs in Snowflake. So for example, if I'm developing like a DBT model, right, and suddenly there is like a cost spike, so I am the analytics engineer, I'm responsible on this cost spike, right? So I need to understand like why it's happened and to investigate it. And once there is like any alerts in the system, I'm the owner of this DBT model. And it's not like the head of data engineering doesn't have any idea why this cost spike happened. It starts to like investigate. So the ownership, it's one of the key pillars in order to make like the cost management maintainable. Because without that, it's not like a one-man job. The ownership again should be like distributed to all of the membership, and we'll discuss about it and to see like how we can actually maintain this ownership. Um, of course, monitoring is pretty obvious, but we'll see like what are the capabilities the Snowflake actually provide us to monitoring our costs in Snowflake, um, and what some improvements that we can do. And of course, the last thing is the optimization. And here it's like where the lineage play like a major role, like how we can optimize our cost. We're going to discuss about something that we call it like usage optimization. Like in a few minutes, you're going to understand what does it mean, usage optimization. Um, but we're less focusing on this presentation on the runtime optimization. It means runtime optimization means like how we can choose the right warehouse size, how we can use like the right features in Snowflake, how we can cluster the table differently. Maybe I should use search optimization. Maybe of course I can optimize the queries and stuff like that. It's a different presentation. If Michael invite me like um, soon, so we can also discuss about like those aren't optimization, but we're going to focus on the usage optimization. In a second, you will like understand more about it. Um, so in this presentation, just that we have like common language between us, like of course, like it's a typical data platform. So we have the data ingestion layer, right? That it can be Fivetran that ingest data from external sources into Snowflake. We have Kafka events that are coming from the operational databases and pushes event into Kafka, and then we stream it into Snowflake using Kafka streams. Most of the time, it's the data engineers that are responsible on this part in the data platform. Then we have the analytics engineer that in this example we're using dbt for that, and we have the consumer layer, right? It can be like BI engineers, data scientists, applications. Again, in this example we're using like Tableau and Direct, and again, it just for the example, it can be um, anything else. So step number one, how we can actually create like good observability. So maybe also after the presentation, I can share with you like a link to the presentation, and you have like links over here for all the dashboard that I mentioned. But for most of the BI tools, if it's like Power BI, Tableau, Looker, Sigma, you have like those templates that you can download and create like a really nice dashboard um, on your costs in Snowflake. So in this example, you can see like over here, it's like a Tableau cost dashboard. But again, all the BI, most of the BI tool has like those templates that you can download, use, connect it to your Snowflake, and get pretty good observability. Um, and also, um, Strato actually released like a really nice dashboard that you can interact with it in their website, but pretty good. Like you can actually see the table usage over there and like some insights and also warehouse utilization, many other stuff. Um, so what is the problem with this like those like observability tools? That is missing the context. So for example, one of the things, and I think that maybe most of you can agree with me, like once we want to start optimizing our like Snowflake environment, most of the time, the first thing that we're do, we're going to the query history. We're going to the query history, sort like the queries based on the duration, start like to understand what are the most expensive queries in the platform, and try to optimize it. The problem with it that we're starting to guess like who is the one that executing those queries. It's like maybe it's like a Power BI dashboard, maybe it's a Fivetran, maybe it's like a DBT model, maybe it's Airflow. Um, so the context is really missing, and this is like the part that like this is like the most like important part. By the way, the context can also be created, for example, by tags. So you can today, like most of the data warehouse and of course also Snowflake provides you like the way to add tags to your queries. So for example, if I'm using Airflow, I can put the tags of the DAG ID and the task ID, and then I can group by those like can group by those tags and get like observability about like what is the cost of the DAG, what is the cost of the task, what is the query, of course, that the DAG is executing, and this context is really important. By the way, also if you're using DBT, for example, there is like a really nice package that you just adding like 3 lines of code into your project, and it tagged you all the queries that executed by DBT. And also it puts some nice comment in the footer of the query with a lot of fields that related to the DBT models with the owner, if it's incremental and many other stuff. I really recommend if you're using DBT, try this package. Again, I can share it in the presentation. But again, the context is super important over here. And in a second, we'll go over like row by row, but you can see, for example, over here also the owners, right? So we talked about it. One of the important things is to start distributing the ownership between the data team members. It could be also the BI engineers, the analytics engineers, data engineers. Again, everyone that interact with Snowflake. And how we can actually maintain those ownerships. So how we can get like this metadata. So think about it. For example, if you're using like DBT, DBT in the YAML, you have like the owner of the data pipeline. So except of using it for the documentation, I can also like use this metadata and start like pushing those like owners and tag it in the queries, and also like aggregate the base of it. So the ownership can be taken again from the YAMLs of DBT. It can also be taken from the, by the way, if you're using Airflow, you also have like owners in part of the fields in the DAG, and also in Tableau. So the ownership again, super important. And why it's so important that again, once I'm like getting any cost spike, I can notify immediately the owner, and not like the head of data engineer or this like senior data engineer that's responsible for the cost in the organization. And then the all ownership is distributed between the team. So by the way, just to emphasize what we're like seeing over here. So we're treating our like our data pipeline a little bit different, and this is the part that we're treating our data asset as a data product. So for example, row number one, it's talking about like a dashboard that call approval rate in Tableau, and then I can see like all the different provider that I'm using in order to create this dashboard. So in this case, of course, it's Tableau, Snowflake, and DBT. Again, in a second, we'll show like how it looks in the lineage, but basically those are like the providers that I'm using in order to create like this dashboard. I have the cost over here, and the cost over here, by the way, includes like any part in the data pipeline that influence on the cost of the approval. So it includes also the extract, for example, that I'm doing in Tableau, fetching the data into Tableau. It's also part of the cost of this like data product, and the duration of it, the number of daily executions, and the usage. We'll talk about the usage in few slides. But again, the context is like super important over here. Let me do zoom in, because I know that you're not like seeing it. All right. So what is this page, and why like why it's important? It's also like the it's also behind the scenes. We're using the lineage over here, and we'll discuss about it in a sec. So basically, this is like a job in DBT called approval rate. I can see like the cost over here of it. So by the way, the cost of like, for example, this like DBT model, it's the queries that DBT generated on top of Snowflake. So today, Snowflake, by the way, they released it, I think, like 6 months ago. You basically have like cost for each query in Snowflake. By the way, one thing to remember that it doesn't include the idle time, the cost of the query. So for example, if the warehouse, you define the auto suspend for like 2 minutes, it will not include the 2 minutes that the warehouse is idle. It's only going to include like the execution time of the query. But Snowflake today provides you like nice table that you can actually join it, the query history with the cost attribution, and to see like what is the cost exactly for each one of the queries. Um, and what we're like seeing over here, basically job in DBT, it's defined by different DBT models. So for each of the DBT models, we actually understand what is the cost of it, what is the performance, and what is the duration. Is the performance, of course, the number of the executions. But important thing over here, and this is where the lineage playing like an important role. I understand what is the downstream of like those DBT models. So for example, like as we mentioned, like in the previous slide, um, the output of those like DBT models, and we can see like the fact and the dim, they generate like a tables. Those tables are used by this dashboard in Tableau. So I can see like here the number of users, the number of views of this dashboard, and this is like one of the important things about like if I wanted to will take like one thing out of this presentation, it's like the usage is like super important. I was head of data engineering and I couldn't really understand what are the assets that are being used, who are the producers of them, um, and there's like a lot of moving parts when you're building a data pipeline. As we said, there's like data engineers, the analytics engineers, the BI engineers, um, and we don't really know, like in the end, how the data pipeline that I created as data engineer actually being used in the end by the stakeholders. And so this is like for the first time that like in a second we'll see like how it looks in the lineage. Uh, but again, what are the output that this like those like DBT models actually serves in the end, and what is the usage of them? In a second, again, we'll see like some nice cost opportunity over there. So we talked about like observability, and again, and we talked about ownership. Step number two, it's like monitoring. Uh, I'm pretty sure that most of you are familiar with like the capabilities that Snowflake has that regarding the resource monitoring and the budget. By the way, the budgeting system that Snowflake added recently, it was I think around like 1 year ago. By the way, Snowflake, and there was a second I will show you like a nice slide of it. Snowflake like 1 year ago like improved their cost management platform dramatically. Uh, Although it's not perfect, but they did like a huge improvements over there. One of the things that they have added is like the budgeting system. Um, but the resource monitoring, for those of you who are not familiar, basically it's a way to define like monitoring on your on account level on or your warehouse level. Um, and you can actually have like two options. If you want to notify when it reached to the threshold of the credits quota, or you want to suspend immediately the warehouse when it's reached to a certain threshold. Of course, you can define like the frequency on a daily, weekly, monthly, even quarterly. Um, the biggest difference between like the resource monitoring and the budgeting that you actually can also define like budget for database and for compute pools, something that you can't really do in the resource monitoring. And the budgeting system, by the way, it's only for notification. The resource monitoring, you can actually define like a rule that it will suspend immediately the warehouse when it's like crossing a specific threshold. And honestly, not a lot of organization using it. Just an example from one of our customers that you can see like over here. So what we're seeing over here, basically it's a warehouse. Um, and we can see like that the cost of the warehouse on a daily basis like $1. And then suddenly there is like a huge cost spike. By the way, it's like an extra small warehouse. So $70 means that the warehouse was up and running for all day. Those are like the things that Snowflake becoming like super expensive. Um, why it's becoming super expensive? Because what is like, I want to understand what is the root cause of it. Why for that we had like a cost spike from $1 a day to like $70. And one of the things that you can see over here, that the average daily execution almost reached to like 9,000 queries daily. Okay, 9,000 query daily. So it means that this specific query repeats on the self, 9,000 daily, like 9,000 on a daily basis. And the problem with it, that the average duration of the query is like 1 second, but the warehouse keep up and running for all day because there is like query that is being executed by a script in this example every 10 seconds. And every 10 seconds means that basically it keeps running the warehouse for all day. In this case, like the customer didn't really have like any idea that the warehouse um, had like this huge cost increase. And by the way, a simple resource monitoring can solve it over here, right? Like let's define resource monitoring daily basis, crossing the threshold of like even $5 daily. But again, the in this case, the customer didn't really have any idea that there is like this cost increase, and probably it will find it out. I don't know, maybe because they defined like an account resource monitoring um, when you start working with Snowflake, and then it getting this notification. Maybe, I don't know. We will find out when he finishes credits. Um, but this is why like the monitoring it's like super important. Um, so where are like the where we can actually improve this mechanism? So first of all, like defining resource monitoring by warehouse, um, it's not enough. I want also to be able to define like those resource monitoring on workflows. So for example, for DAGs or for jobs in dbt, or even for extracting that is happening using Power BI or using Snowflake, or even I want to do it by users or by domains. So the granularity of warehouses, it's not enough. Um, and also, we can pretty easily create an anomaly detection system, right? So 80% of most of the data platform costs, it's like for those ETL processes, and those processes are pretty deterministic. So it's not hard to predict what is going to be the cost the day after. You saw that in the previous in the previous slide, the cost was like $1 daily, and then there's like a huge cost spike. Anomaly detection system can pretty easily understand like the trends and to send you like a notification once there is like changes in the normal behavior. Um, and by the way, like Snowflake also today has like those internal models also for anomaly detection that you can use. Um, Another disadvantage like that there like for the resource monitoring is the notification system, that you can send like a notification only to email today. But Snowflake again recently added like a way also to, it's not that easy, but they also like added like a notification system, SQL based, that you can actually get also notification to Slack. For Teams, I'm not actually familiar with, but I'm pretty sure that there is like a hacks in order to make it happen to send like notifications um, also to other providers. And notifications to emails, it's not enough. Like if you want to do monitoring your cost on a daily basis, um, it's need to happen where the most of the communications happens between engineers, and most of the time it happens on those tools like Slack, Teams. Um, so while monitoring, yeah, another important thing. So we have like a cost spike, right? And in the previous example, we understand like pretty easily that those like the, so I can actually see like over here the change in dollars. And so it's like pretty easy to understand like what was the root cause over here. And probably one that's like the one that's familiar with like this process understand, oh my god, it's like executing for all day. It used to execute it like only once. It should be executed only once a day. Why it's keep running like all day? But sometimes understanding the root cause, it's not that easy, because I have like a workflow, like a DAG workflow that execute DBT's models, and then I need to understand like what happened inside the DBT. So let me go to show you like a nice example of the root cause analysis over here. So for example, I have like a cost increase in this like KPI dashboard of 6%. I'm pressing on it and I can see like all the related jobs, all the DBT models that basically modeling the data for this dashboard. And I can see like there is like a cost spike that started like 10 days ago. I can also see like exactly the DBT model that's responsible on this cost spike. And the cool part over here that I can actually see immediately the root cause. And what happened over here, that the analytics engineer changed something in the query, in the DBT model, and he removed the filters. And then suddenly where I'm like, it's increasing much more data. It's it's scanning much more data. Um, and this is what happened. Like this is the root cause why we have this cost spike. So changes in the query. By the way, cost spike can happen like there is not like a lot of reason why like cost spike can happen. Again, changes in the query. Maybe someone changed the size of the row, so it's increased it from extra small to small. Maybe I have like more data in the sources, um, and ETLs need to process more data, so it takes more time. Um, or maybe I change the frequency of the job, and suddenly there is like huge cost increase because of the frequency of the job. Again, there is no like a lot of cause why the can a cost spike can happen, um, but again, the root cause, it's something that it's like super time consuming, and and we need to solve it somehow. All right. Optimization, optimization, optimization. So as I mentioned in the beginning of the presentation, um, we divided it like to um, two main optimizations. One is the usage-based optimization, and one is the runtime-based optimization. A reminder, the runtime optimization, it's like for the queries, how to choose the right routes, how to define better the table, maybe to cluster it differently, maybe to use like feature of Snowflake, like materialized views or clustering columns, search optimization. But we're focusing mainly right now on the usage-based optimization. So as I mentioned, Snowflake did like a really nice improvement to the cost management section. And you can see over here the cost insights. So what it means, Snowflake actually provides you some nice insights. So for example, large tables that are never queried, tables where the data written but not read. Maybe you define like a materialized view, but no one is using no one is using this materialized view, or no one is using the columns that the materialized view is actually built. So Snowflake provide you like a really nice cost insight. If you are not familiar with it, logging into Snowflake. Of course, if you're account admin, you can log in into it and to see like maybe some nice insights. The things that we discussed about, also the budget is over here, the resource monitoring. And again, it has like nice observability, but unfortunately not enough. We need to do some work in order to make the observability actually work for us. So yeah, let me zoom in also over here. Um, so we talked about it that we changed like our approach and we're not like we're starting treating differently to the data asset, and we're trying to treat it as a data product. How the what are the output, what are the outcome um, of the data pipelines that we're building, and and again, one of the metrics that we also like mentioned in previous slides ago, it's it's the usage, right? So for example, I have like a settlement report over here in Tableau that again is generated by DBT on top of Snowflake, and I can see that the average daily execution of this data pipeline, it's like hourly basis, 24 times a day, but the usage of it is like only 8 hours a day. And this is like the interesting part over here. So let me show you how we can actually optimize it. And okay, let me do like also zoom in over here. So this is like the place that again the lineage play like important role. So let's do it from the downstream to the upstream, from right to left. So as we said, like in this example it's the approval rate, but I mentioned the settlement. But let's focus on the approval rate over here. So what I'm seeing over here, it's like the daily usage trend. All right, so when I can see like that the dashboard, it's only being viewed like during the working hours between 8 a.m. to 8 p.m. And so over here, it's like the views that actually the users that open the dashboard. Then I'm starting to climb over the tree, over the lineage, and I can see that the one that actually feeding this dashboard is like extracting Tableau, right? You can also see the cost of this extract. What does this cost mean? It's the queries that being executed by this extract. It's not like the Tableau cost that maybe it has. It's the cost that this like extract generate on top of Snowflake. Of course, you can also see like the performance over here, but we're focusing mainly on the cost right now. But if if the BI engineer didn't define like optimal query in the extract, so or of course also by the dashboards, we can also see it like of course over here in the lineage, but again focusing mainly on cost, and the cost is over time over here. So this extract like is consuming the data from this like table. This table is being generated by this DBT model. And also here, of course, it's like the cost of the modeling the data. By the way, in this like example, it's the cost of the queries in Snowflake and also the cost of DBT. Um, and then we have like a split over here in the lineage. So you can see the approval rate table. It's actually being used by other use case, by other data product. In this case, it's like a merchant report app. It's like a React application to consume the data from this merchant report table. But over here, I can see that the usage it's like for all day. So not only during the working hours. So in this use case, um, we actually generate like an insight over here that you can change the frequency and disable data pipeline during the night, for example. So think about it, how many opportunities you actually have in your data platform for like those data pipeline that um, that maybe no one consuming it during the weekend, so no one consuming it during the night, and maybe the dashboard was abandoned and it's not using anymore, and I'm still like keep refreshing the data by the extract of the data source, or I'm still keeping modeling the data for this specific use case. And by the way, it can be also from the data ingestion. So for example, if this in this example, we're using Fivetran, that ingest data from external sources. Let's take, for example, it's take data from Salesforce and push it into Snowflake. Um, Maybe no one is using this like table in Snowflake anymore, and I can turn off the connector in Fivetran and save the money over there. And we're seeing those examples so many times. So the key metric over here, it's like the usage. Of course, also the cost like play like a major role over here, because I want to understand, of course, how much money I can save by this like cost opportunity. Um, but there is like also a lot of good side effects when you turning off those data pipeline or change the frequency of the data pipeline, because it can also help you reduce the complexity of the system. We know for data pipeline that runs every 15 minutes, or data pipeline that runs once a day, the level of complexity for data pipeline that runs every 15 minutes, it's higher compared to data pipeline again that runs every day, or maybe data pipeline that I can turn off that um, um, the outcome of the data pipeline, like no one using the data product that the data pipeline generates. All right, cool. So again, we took like the lineage over here, and we put like a lot of metrics on top of it, and it's related to usage, to cost, to performance, to freshness, to volume, in order to find like a lot of cost insight opportunity over here. And and we also using, of course, the lineage to help us to understand, like to generate those insights, but it's also help us to show you exactly uh, how we reach this insight. So it's easier to understand through the lineage. All right, so I can actually understand that how exactly we reach to the insight, and it's like give confidence to the users when they're like disabling data pipeline, to understand there are not like impact on any other like any other data product in the system. Um, yeah, I really like this post. Like I think that um, most of the data engineer, like anyone in the data team, actually feels it, that a lot of time there is like a huge discrepancy between how the stakeholder asks us the data and how the data is actually being used. So we discussed like a lot about it, like those discrepancies between the usage and how the data is being produced. So I think that I didn't really do it that way, that I asked the right question from the beginning. So for example, if someone comes to you and tell you that he wants to see the data refreshed in real time, um, I didn't really ask like the question, do you really need it to like in real time? Do you really need like to, what is the frequency that you're going to use like this like dashboard? What is the frequency that you're going to consume the data from those like tables? And so of course it's all about prevention, but in the end, I also need those like monitoring system um, in order to understand what are the assets that are being used right now, what not, what I can delete, what I can disable. And so, but again, in the beginning, it's all about prevention. And I know that there is like again, there is like a huge hype on data product, and there is like not a clear definition what it is. But um, for me, like the what makes it clear, it's like that I'm starting to treat the outcomes of the data pipelines. Those are for me like the data products, and stop like treating on like stop like thinking about data pipelines, start thinking about what is the outcome of those data pipelines. For like the way that we like I see it and we see it, it's like those are like for us the data product. And once I'm defining well what are the data products in my system, um, monitoring the usage, the cost, the performance. It's something that needs to be like embedded in those in those data products. And think about it that I'm like, if I'm a software engineer, probably if I'm developing like a new feature, I have like the product manager that create like the that is monitoring how this new feature actually being used by the customers. So we as a data engineers, we need to create like this observability by ourselves. Um, but it's something like super important because in the end, this is like the way that our users interact with the things that we are building. Um, and yeah, we're seeing that like 50%, 50% of like this is like the average with our customer that the cost saving opportunity we're seeing by those like we call it like waste reduction and those usage optimization that we discussed about. And so just by that, we're seeing like a lot of opportunities how you can save like a lot of money. And and again, the combination of usage optimization and runtime optimization is this like um, the perfect solution. But first of all, let's remove and optimize all the things that doesn't really bring value to the organization. And that's it, I think.
Great. Thanks. And I think we are right on time for the Q&A. There's actually a question. I'm going to ask us to, you can unmute. I think everybody, you have the ability to unmute if you have a question. So maybe I'll just call upon, he's actually a senior colleague. The Fonka, do you want to ask your question? I hope he's
Sure.
still in. Great. Yes,
Yeah,
yes.
thank
Please.
you. Thank you, Mayor. Thank you so much, guys. Very, very insightful, valuable here session. I'm listening to it, and because we started looking into Snowflake in our organization, it's still not there, but I'm just looking into what can be used there. So one of the point you mentioned at your earlier, like last 15, 20 minutes, you're talking about the DBT a few times. We don't use the DBT, but we have
Yeah.
Azure Data Factory, which is similar ETL tool, SaaS based. So I'm just wondering the things you mentioned about the model, DBT model. I'm not sure I understood that DBT model. So if I think about
Yes.
ADF, because ADF doesn't have the model, so can you just a little bit explain a little there?
Yes, of course, of course. So maybe I like repeated DBT too many times, but in the end, it doesn't really like in the end, DBT generates like queries, right? So the idea is to monitoring the queries that DBT generates. In your case, you're using Data Factory, right? You said?
Correct. That's correct.
Yeah.
Azure Data Factory.
Yeah. So in Data Factory, like correct me if I'm wrong, but all the heavy lifting of the ETL happens inside Snowflake, right? Like it generates the query, or Data Factory, it's actually doing the.
So, so through the Azure Data Factory, say for example, we connect the source system, we'll do all this ETL work, and then we push the data to the Snowflake. So I don't think it will do computing in the Snowflake, but however, the process and clean data will be pushed to Snowflake, as an example.
All right, so you're pushing this like data from like using Data Factory, the raw data into Snowflake, and then you're doing like all the aggregation and stuff like that inside Snowflake, right?
Correct.
Yeah,
You're right.
cool. So think about it like about your Data Factory, right? Like he wants, for example, you created like a lot of pipeline in your Data Factory that pushes data into Snowflake, into those tables. One of the things that you want to somehow correlate it's between what are the data factors, like what are the pipeline or data factor that actually like to which table it's connect, right? And how this table is being used. Why? Because maybe you created like a several pipelines in your Data Factory um, that pushes data into Snowflake to those tables, but no one is actually consuming those tables anymore. So The idea over here, it's again, it doesn't really matter if it's like DBT, data factory, it's like a task in Snowflake. In the end, it's who are the producers and who are the consumers. This is like the thing that you need to like try to solve. And maybe if you had like the option, I'm not sure in Data Factory that you have the option, but maybe if you have the option to inject, for example, tags to those like data pipeline and give like the context who is writing the data to those tables. So for example, the data factory ID, and then try to build like in Snowflake, like, okay, I have this table, I know who is writing data to it because I see like the merge, the insert into queries, and then, okay, I can actually find the tags, the data factory. I know that those are like the pipeline in data factory that's responsible on just the data, but no one is actually using those tables anymore. So again, the whole idea it doesn't really matter what is like what is the tool that you're using. In the end, it generates like queries on top of Snowflake, and the idea is to somehow enrich the context of those queries, because every time they're trying to guess like who is the executor of them, this is like the hard part, because you don't want to spend like hours in the query history and understand why were they the one that executed those queries. So again, it doesn't really matter it's like DBT or not. It's like in the end, who is responsible for those queries.
Thank you so much, guy. If you allow me, I have another question.
Of course.
Thank you. So in terms of orchestration, right? In Snowflake, I know you can write all the SQL query, but as like you mentioned with the DBT, is that you use the DBT to orchestrate that kind of pipeline? And okay.
So yeah, like basically DBT helps you in the end to generate like queries as a code. And you have like two options to work with DBT, or you're using like the open source, it's called like DBT Core, or you're using like DBT Cloud that gives you also the orchestration layer. So basically it's like the scheduler. And of course, it's also give you like other nice capabilities that relate to quality and nice IDE. But in the end, the whole idea of DBT is to be able to generate those queries more like as a software engineer that develop those queries, instead of like have like huge dump of like query that it's really hard to maintain in them. So it's basically gives you the ability to start maintaining those queries as a code, instead of like trying to maintain those like huge queries. So yeah, and
Okay,
you
for
have like
example,
two
if
options.
someone doesn't have, for example, someone doesn't have the DDP, is there any native orchestration built in Snowflake, or any other tool also can do the orchestration? I'm just thinking if we don't end up having DBT because we're kind of
Yes.
Okay.
Yeah. You have like you have like a lot of way like right now. Snowflake first of all has its own scheduler. You can use task for it. You can use also dynamic tables for it. So there's like a lot of options to schedule like a different queries in your Snowflake. So if you don't want to insert like a new tool like Airflow, DBT Cloud, there's like huge bunch of like tools over there in the industry right now. Snowflake has its own capabilities to do it. I can share it like in the presentation as well, if it's something that interests you.
Thank you so much, man. Thanks.
Thanks. And anyone has any question? I know we're nearing the time, but Guy, what's the time for you? I'm gonna be like, I hope
It's like a 2 a.m. in the
oh
UK.
my God, sorry,
No, it's okay.
stressing you out. hope you don't mind for maybe like 3-4 more questions, because I've got 2 house questions, from we the host. And is it okay if we take maybe 5 more minutes of your time?
Yes, of course.
Okay, great. And so he's generously agreed to 3-4 more questions. If anybody wants to take a question slot before I take the 2 other question slots, anyone got a question? Okay, so if you want, you can raise your hand and kind of unmute. So question number 1, guy, it's more about I find that in other sessions that I moderate, whenever we get the speaker to talk about their unique journey, a lot of people, because always a mixed audience, we have some people who they came for the core content, and then there are some who they also want to hear more about how they can grow into the expertise that the presenter already exhibits and has. So in your case, the question would be, what was your journey like? Have you always been doing data engineering? Did you always know you were going to start Seemore Data? Have you, was it something that was well laid out for you and it was just smooth road, or what was it like from start for you?
Wow, it's a good question. Actually, I started my journey as a software engineer, um, and then in a certain point, like I looked on what the data team is building, um, and I was really like it really interests me. So they used back then like Spark and Kafka and Druid and Cassandra and many other and many other tools that many other technologies that I really um, really fascinated me. So I started reading about them, and then at a certain point I decided that I wanted to move to the data space. And so a lot of principles that I had like as a software engineer, I took it to the data space. So for example, I know that right now it's more common to write like tests on your data, but if you have someone like 10 years ago to write like unit test, like it was like not something that was common. And but right now, like a lot of data engineer write tests. So they're doing like those nice quality checks. They create like there's like a huge amount of like data observability tools that checks the freshness of the data and the volumes and stuff like that. So um, I think that if you want to see like how the um, data engineering space is going to look like in 5 years, you can look on how the software engineering is looking right now. And so yeah, like I fall in love in the data space. Like I think it also has like a huge opportunity right now because everyone's talking about AI, and I think that the data teams are going to play like a huge role in this space, and because in the end, like the place that you have like all the data from all your organization in one place is your data warehouse. Um, so yeah, and we can discuss a lot about like how this role of data engineering is changing because of all the revolution of the AI. But I think it's a big topic.
Well, thanks. And I liked how you explained that if we want to see the future of data engineering, just look at what the software engineering space is like, and it's all those best practices there and what current data is going to become necessary in data engineering. That's a very good thing. That's giving me a pattern of what to learn. Thanks. So the second question I want to ask is, you've tried to hint about it, but I've got a proper question for it. What's the landscape? If you look at the current landscape of, I like the fact that you are even at the forefront because you've gone from working for organizations, you've gone from doing these as one of the people within a company, doing this to actually building the tools that companies are going to use because you built these leading the technical team at Seemore, and it's out, and it was based on what you've seen that you think can be done better that are not there in, organizations. And so my
Yeah.
question is, you are better placed to kind of see trends, and your background even makes you see things that are not so obvious to the rest of us. So if you want to give your honest take on what the landscape is right now, what you think is not going to be, that is common practice that is not meant to be happening anymore and will eventually cease to happen, and what you think will be the norm in the next two, maybe 1 2 years, and someone who is playing in this space needs to be aware of and prepare for, what will that be?
Yeah. So I think that one of the changes that happen in the data industry, and I really like it, it's that, think about it as Snowflake and Databricks, for example, they are not like data warehouse anymore. They are like, they call themselves like a data cloud provider. And the reason for that, it's like that Snowflake and Databricks are not really like taking all the responsibility on your data. You can actually right now create like models inside Snowflake and Databricks, right? So if you want to create like AI or an ML model, you can do it. Or they have like, they invest like a lot of like money on like on those native apps. So if, for example, I want to create like a React application that interacts with the data, I can do it directly in Snowflake right now. I don't need to like they develop like a whole framework that you can deploy those application. So this trend of like, we're not data warehouse anymore. We actually managing more stuff. This is why I think the role of data engineering is changing, because you are not only responsible on the data warehouse. There is like a lot of stuff that's happening inside your Snowflake environment that you need to be aware of, especially, by the way, also for cost things, because all right, like I want to train those models inside Snowflake. It comes with with like cost outcome out of it. So in the end, the trend right now that there is like a huge consolidation. Like I think that it's funny, but because I'm right now I'm building like a startup that is also like kind of a new category, but in the end there is like a lot of consolidation in data space, because data engineers doesn't want to like hold like a lot of tools. So I don't want to have like a tool for data observability, for data quality, um, for cost management, and I want to have like all in one place. This is why we're seeing Databricks basically have like their own data catalog right now. Also Snowflake, you can create like those data quality checks inside Snowflake and inside Databricks. So like those giants actually have like more capabilities in their system from many aspects. So again, the trend right now, that two main things. First of all, the consolidation, and also like the data warehouses are not data warehouses anymore. They're like data cloud that gives you like a lot of capabilities inside of it, and that it gives us, the data engineers, like a lot of you know a lot of power. Yeah.
Oh, thanks. And I like the way you rounded it, like it's going to be data cloud. If you think about what AWS and Azure did to the whole way software engineering used to be 10, 15 years ago, it seems what you're explaining now is Databricks, Snowflakes are going to be that kind of a platform, and a one shop for everything that a data professional is going to be using, and everything will just be in one platform.
Exactly.
That's really powerful. So thanks. And I think at this juncture, we're going to bring it to a close. I just need to again announce to everybody who has who has stayed back till now, that at least thank you, and you should, about the recording and something else. Let me just share my screen, and that will be the wrap. So this is the session we are in today. And thanks again to Guy for making this as interactive, and staying up at 1 a.m. till past 2 a.m. I'm going to let him go sleep soon. But next month and the 2 months after that, up until May, we've got events lined up. In March, we're gonna have City of Toronto, someone, the supervisor of City of Toronto Open Data Program, present to us. So you want to sign up for all these events. In May, we're gonna have another person come present to us on Enterprise Data Lake and Data Warehouse. In April, one of us, let me check if he's still on the call, Sabine, I think he's had to go. He's presenting to us on Python. He's not yet decided what he will be. He says he's still building the demo he wants to do. So we've got events lined up, So check out the events. That would be how I'm typing it. Check out the events at here so you don't miss them. And thank you once again, Guy. This is where we're going to bring this session to a close. As for the recording, I will send it to everyone, and maybe I'll also let Guy know where to find the recording, just in case you also want some people in your community to benefit. But thank you very much to everyone. Thanks a lot, Guy, for this amazing
Thank you,
session.
everyone.
And I'm sure we're going to have you back in the future. Just let us know. You've
All right.
proposed about 3 topics. Let us know which one you want to
All
talk
right.
about first and when it's okay for you. I know you're also busy and the timing is something that also makes it difficult, but we're always happy to have you again. Thank you very much.
Thank you so much.
Thank you to everyone. See you all next month.
Bye.
Bye.